Okay, normally we do quadratic factorizing, but this one is not factorizable. So your job is to show why there is no stationary point. So to show that, do the discriminant, which is your b squared minus 4ac, and b is 2 squared minus 4ac, c is 2. Yes. 4ac. What is your number? B squared minus 4ac, which is not good. Okay, you end up, what is your equations for that question? Your equation is
minus x squared minus 2x minus 2.
Why the equation is difference? Differentiate minus 2 is differentiate 2x plus 2. Right. Okay, this one should be a minus, that one should be a minus. Your extensions. Yep. You're also probably doing the same mistake as well.
So what did you get?
There you go. This is a bracket.
All around the whole thing?
Yes, this whole thing
I
should be
got
minus.
minus 12.
Mm.
And
Yes,
then minus 12
you
is
left out,
less
yeah.
than 0. So,
No,
that's
what
So you meant to get 4x.
Hmm?
Minus 4x.
Yeah, minus 4x and minus 2.
minus x
Yes.
squared minus 2x minus
Yes. So this is not right. So you are going to have minus x squared minus 4x minus 2 equal to 0. So discriminant is going to be the difference. 16 minus 4ac, which is minus 4x. Should be a 2x.
Oh my god,
Should
do you
it
know
be a
I'm not being
2x?
knocked today?
Because isn't it
I saw it, I was all
minus
black.
2?
This one cross up.
Oh,
Yes.
facts.
So
How do you
this
know?
one is
Nothing
2x.
told me.
So this is a 4. You get minus 4.
Did he go home?
No.
What? Why not?
Because why is he gonna tell his parents that he got beaten up? Is he dumb?
Yeah, but didn't they beat him up first? Like he didn't start it, did he?
He was incorporated with it.
Oh, okay.
Okay, yes. When discriminant less than 0, that means no stationary point. Yeah, no solution. It means no stationary point. Your b is 2.
Oh,
Yes. Yeah.
wait. Oh, the one of this is minus 1.
Okay, so no stationary point then, because this is a rational function. Few more things that you need to do as what we learned earlier last year or later end of last year about the asymptotes. Remember that? No. Okay. So for the asymptotes, what you are going to do for any vertical asymptote, look at the denominator. So you are going to have x squared plus 2x equal to 0 and solve for it for the asymptotes. Yes.
For which one, vertical?
For vertical, yes. To find vertical asymptote, you put the denominator equal to 0 because denominator cannot equal to 0. Is that right? Yeah, that is unsolvable. That go to infinity. That's why you put it equal to 0. Then you factorize, common factor, pull it out, and therefore you have x equal to 0 or x equal to minus 2. And those will be your two vertical. And for the horizontal asymptote, remember you do the limit, this one. This is a formal way to do it. Yeah, if you get these type of questions this year, this is what you need to write. And you divide it by the highest degree of the denominator. Okay, the highest degree of the denominator is x squared. So this is your highest degree, so divide every single term by x squared. So you are going to do over x squared, over x squared, over x
Is this to
squared.
find the...
Horizontal asymptote. This is your vertical asymptote. This one to find horizontal asymptote.
So you times it by the highest degree?
Divided by the highest degree of the denominator.
Times every term?
Divide every term
Oh, divide that by.
yep. And therefore you are going to get x approach infinity. You are going to have 1 on x, 1 on x squared. You have 1 plus 2 on x. So all this term in here is going to turn out to be 0. Because you can think of 1 over, because x is approaching infinity, so that means you think about this one, x over a huge number.
Yeah.
So that turned out to be 0. So therefore you are going to have 0 over 1, which is equal to 0. So y equal to 0 is a horizontal asymptote. Making sense? Everything? Yeah. So now,
Wait, where's
having,
Hui?
Hmm?
Where's Hui?
oh, on the concert, Hui, right?
She there?
No, she's going to see the recording. Yes. Okay. Asymptote. First thing, put in your asymptote into your diagram. X equal to 0.
Oh, yes.
Yes, you do have to sketch it. Yeah, x equal to 0, which is this line. And x equal to 2, which is right there. 2 or minus 2? Minus 2, wrong way. 2, oops. Minus 2. Ooh. And no asymptote, so no turning point. So what should we do? We kind of having a really empty one. Horizontal, yes, you have one more, which is y equal to 0. Okay, this is the case when you have to do the point testing. Test a point, anything in here, any point. Pick a point. If I pick a 1 into the equations and see where it is. Okay, if you pick a 1, or you can pick a 100 in here, put into the equation, put that in calculator.
100.
100, 1,000, doesn't matter. 5, any number.
Into the normal equation or the...
Normal equation, I want to find out the coordinate of the point. Put in any coordinate of your x. Anything greater than 0.
0.0099.
Okay, that is a big number, right? When you put in, okay, so when it is at 1,000, you have 0.099, which is right here. So you know the curve have to approaching asymptote, which is this way. So it has to come from here. Make sense? Yeah, that's how you sketch that branch of the curve. All good? All right. So the next thing I need to know is that whether it cut through the y, what is the x-axis. So to find where it cut the x-axis, what do? You put x-intercept. How do you find out the x-intercept? You put y equal to 0. Yep, you sub in y equal to 0 into your equations. You are going to get x equal to minus 1.
Yep.
Yep. So you know it cut through at minus 1 here. So this is your point. Minus 1 is where it cut through. So my curve have 2 options now. I know it cut through here. So that means either my curve is going down this way, or it can be going down that way. So again, test a point using the same formula again. Put in either minus 0.5 or put in minus 1.5, 1.9, any number. Okay, see whether it come down from here or it go down there.
I thought there was a y asymptote.
Oh, what? The y? This one? Okay, how can it cut through, right? Yes, you can always cut through. The meaning of horizontal asymptote is when the curve come to really big x value, it is where it's approaching. In between, you can cut through it. Okay, so you can cut through the horizontal asymptote, but you cannot cut through the vertical asymptote. So what's the number you have?
Minus 0.666.
For
Minus
0.5 minus 0.6, that means it's here. So you know the curve is going to come down that way. So you are going to have a curve that is something like that. Don't draw it so straight, a bit more curvy.
Yeah.
Okay? Yes, but there is no, try not to do it this way too. There is no, what is that, bang, no horizontal, no, horizontal point of inflection. It's not, it's just cut through. Okay?
So it's just a straight line?
Not straight, but don't draw like this, okay? Something not to do, don't draw it straight like this. Don't draw it too straight. I will probably more like have it closer and then cut more like this. Make sure it's not a straight line. Don't use a ruler. Yeah, as long as you don't use a ruler, it's not going to be super straight. Yeah, all good? So as it goes this side, it have to approaching the asymptote because you know there's an asymptote, it have to approach and then you have to approach there. So I will not make it obvious. Make sure you don't do this one. Yeah, it's not to do. Okay, so any other things is fine. Okay, last point to put in. Put in anything less than minus 2 and see whether it's here or it's there. If you get a negative number, it's here. If you get a positive number, you will get that. Oh, good. So this is a type of questions that you don't have much information literally trying out your number.
So what should I say?
Oh, any number. Less than minus 2. Minus 3 is fine. Is that alright?
Yeah,
Yeah,
it's
makes
so
sense.
difficult.
Yeah. Rational function is a bit trickier. It's a lot more work than the usual.
Minus 2 over 3.
Minus 2 over 3 again is negative, so it's going to be on the bottom. So your curve is going to go down this way. That's what the curve is going to look like. Yeah. Okay.
Can we leave question 8 for homework if it's the same thing?
Not the same. I want you to try it out, and then I will give you more of the rational functions. Yes, to practice on. Then we go on to application. Yeah. Questions, yeah?
No, it's okay.
It's okay. Yeah.
I got this. I don't know if it's right.
Yeah, that's fine. So therefore your x equal to 0. Yeah. And sub in, we find out the y. Oh, by looking at it, and you sub in the 0 into here.
Oh, yes,
Yeah. So you know the turning point is at 0, 0. And now we are doing the determine the nature. Are you going to differentiate this again, or you want to use? It's easier to use a table value.
Oh, do I have to do that?
You don't have to. You can differentiate using the second derivative. Do you think this is easy to differentiate? I probably will not do it
Okay.
because you have a quotient rule and then you have a chain rule.
Okay.
Yes, I probably will go. That's why you learn the table value, so that will be the easier way to do it. Okay.
Wait, I don't know what I'm doing wrong for 5C sketch.
The curve. So positive going this way. Draw a line that is
But
facing.
I don't know if it's like,
What is that?
isn't it supposed to be like 5, 7?
Don't have to be scale. What do you mean by 5, 7?
Like, this is X and this is Y.
This is y dash.
Oh yeah, Y dash.
Y dash means gradient. 7 means positive. You draw a line that way. You draw underneath the slope of the curve.
So, wait, what?
This is not the coordinate. 7 means the gradient is 7. When the gradient is 7, it's facing that way.
Mm-hmm.
So
it's
you draw
positive.
You draw a positive here.
From 0.
You draw it. Positive, 0, negative, 0, positive. That's what the curve looks like.
Yeah, so how do I draw it on a graph?
This is your coordinate, which is, what is this coordinate? When it is at 1, what is the y coordinate?
Oh, so I need to do both the coordinates.
Coordinate is for the graph, this is for gradient.
Or for like the direction.
If you want to think of gradient as direction, yes, you can.
Okay.
And I just
Okay.
sub these
Yep.
into
Yeah, if you
this
sub
one.
into here, yes, that's right. Into which equation did you sub into?
Derivative.
Yes. Make sure you put a y dash, otherwise not the derivative. Yeah. You don't enter it this way, you're going to waste like 5 minutes just entering data. What is your equations?
This one.
This one is your equations. Yeah. If you want to enter minus 1, you want to enter 1. 1 equal. Yep, and then you have answer to the power 3. Press answer. Bring out your answer. Yep, to the power 3.
Wait, one minute.
Minus. Continue.
Minus
Mhm.
5.
Answer.
Do I bracket it?
No, we got it. Answer square. Plus 7 answer. Minus 14. Yep. Okay, so when it is at 1, you have 11. So 11 is a coordinate.
It's not minus 11.
Yeah, minus 11. 1 minus 11. And then if you need the other one is 3, right? Is that 3? 0?
7 over 3.
7 over 3. So we put 7 over 3 in the calculator. 7 over 3 equal. Bring it up. Equal. Yes.
Oh, wow.
You should know this one time when you say this.
No.
Positive, 0, negative. So this is what type of turning point is this?
You should know
Like
that.
It's not.
This.
What is the shape
No,
look
it's
like?
in it.
What's the curve look like when you have it like that?
Hyperbola, it's
No, no,
negative.
no, no, no. This one. This one. What's the curve? These sections. Here.
What question do you want?
Yeah. What type of
You're
turning
doing
point is
the
this?
one from before.
If you have curve going this
It's
way.
8 or 7?
Negative?
Negative,
Five.
why is this negative?
Because I didn't graph it.
Your curve, that is why you sketch that. Your curve is having it as positive. Okay, you are not using what you have. So what you have in here, you have it this, that, and that. That means your curve look like that.
Yeah.
Is this a minimum point?
Maximum.
Yeah. Don't give me random things. Okay, you should have your stationary point on part A of the questions. Because part A of the questions normally I ask you to find the stationary point. Okay? Point, that means you need to have the x and you need to have the y.
Yeah.
Yeah. So you should be completing all the x and y on the part 1. Otherwise, you are not complete your part A. That will lose 1 or 2 marks that you are going to be gone. Alright?
Okay.
Yes, okay. Right. So
We're on
have
the
you,
right track.
yep, so you have your coordinate which is 1 minus 1. Wait, 1 minus 11. Have you plotted it?
Yeah.
Yep. Okay, put in the coordinate 1 minus 11. We just put a dot. Right. So vertical asymptote. Good. Now you draw your graph. Horizontal asymptote.
Oh, it goes back down.
Okay. So and then yes, it's back down. So it's
2
like
minus 12. So here.
2 minus 12. Yep. So this one is a max point. This one is a min point. So your curve going to go down. Yep. From yes, going up and then go down and up again. Don't stop there. This is the lowest point. This is your minimum point, right? Minimum. That means you see your curve go down and you stop here. You need to curve up.
How? Like that.
Okay, so far this is what you have. This is your axis. You draw going down. This is maximum, minimum point. So that means you need to curve up. You just cannot just stop there.
Okay.
So all the maximum point. So when you label it, maximum point is here. You should have something look like this. Minimum point is there. You should have something look like that. Then you literally are joining dot to dot. Making sense? That's why your curve look like this. Your actual curve should be going down here and turn in here, go down, turn, and then turn again, going down again. Yeah. Does it make it easier?
I think so.
Okay, so you divide by x squared. Good.
Oh, I
Ooh,
just
are you
ran
sure
out
it's
of
one?
white out.
0? This one turned out to be
Just
No.
then.
nothing mean.
0.
Are you sure?
1.
Yes.
1
Yes.
over 1 minus 4 equals 1 over minus 3.
No. This one is 4 over x squared. So you let find x squared. So 1 over
1
minus
minus 4 over x.
4 over x squared is going to give you
0.
So that means it's 1 over,
1.
which is
1.
that's it. Good. Now put in all your asymptote and then put in your local maximum into the graph, and then we will check the rest of the point. x squared, x squared, x squared. Yeah, okay, you left out your over
Oh.
x squared. Right, otherwise looking good. So, and 4 over x squared giving you 4 over x squared. X is because you left out this thing.
Oh.
Yes, here, need to write here. After the equal sign.
Oh.
Yeah. So now you are thinking of the number is infinity. 4 over of infinity, huge
So
number.
0.
Right. So that
Unless
means
you're
you.
bleeding excessively.
Oh, what?
What did you do to yourself?
I don't know.
Wait, so then
Right.
you get
Yeah, asymptote.
so
Yes.
it's just 1.
Yes. Y equal to 1 is your horizontal asymptote.
No, this picture.
Mm-hmm.
Alright. Y equal to 1 and the vertical is at 2 and minus 2. Good. Yep. And you have one turning point. Yeah.
At 0, 0.
Yep, it's 0, 0. So you have it at minus 2. And you have it at 2. And what type of turning point is that?
Maximum.
Maximum. So that means it should be, which way? Should I look like this or should we look like that? Yeah, draw it up. Yeah, maximum point.
And then
Right.
it's like that.
Where's your turning point?
Here.
No.
Wait,
Yeah.
it's like that.
Yes,
Wait, why
it's
is
like
there
that.
why is there a y-axis?
That is your horizontal asymptote. Yeah, right. Rub it off.
Oh,
that is
but
your y equal to 1.
oh, it just exists up there.
No, we still have more to sketch. You see, I got nothing on this side of the curve. There is nothing there.
How do you know where there's supposed to be something?
That's when we do the sub in number.
Oh,
Put your calculator, sub in a number, any number in here. Any number. You can have it at 3, at 4, 5, 6, or you can try a number which is 1000. Any of the number. Try one number. I only need one.
Are you guys doing 8?
Yes, we are doing 8.
9 over 5.
9 over
For
5.
3.
What's that?
X
9
3.
over 5. That means 1 point
Which one
something.
did you sub it into though? Do you sub it into this one?
Okay, yeah.
The
Into that one,
original.
you're fine, both you are fine. She sub in a number which is here, you sub in a number. So that means it should be on top of the 1 or it should be on the bottom of the 1. The number you have. On top, right?
Yeah.
On top.
On top.
Yeah.
Yeah,
The
on
1.8.
top. That means what you do is you sketch a curve on top. That's what you do. I only need one number to decide whether it's on top or on the bottom. Then do the same thing with negative. Yeah. Okay, on top again. So that means it's on top. So make sure you don't just sketch. One thing not to do, make sure you don't just sketch this one and leave them open up. That means your curve only have halfway through. Alright?
What kind of curve is this?
What type of curve? It is look like hyperbola, but it's not quite the usual hyperbola you're having.
Oh, okay.
Yes, yes.
So it's just like a
Mm.
graph.
This also called a hyperbola.
Oh.
It's just a more complex one.
How do you know where you're meant to test the points?
Ah.
Or is it just based off the estimate?
Based on the graph, this is what I have. That's why I don't test any point in here. This is already done for me. Okay, so this is the empty section. I got no graph in here. That's why I need to test a point. Yeah, this is empty sections. I need to know whether it's approaching, this is my asymptote, is approaching from the top or from the bottom.
Is it possible for you not to have a graph there?
No.
Oh, okay.
Because it's a function. Everywhere on the x-axis, I have to have number.
Mm.
I have to have part of the graph. Yes. Any other
Wait,
questions?
how does the
Yeah.
horizontal asymptote work?
This one here, limit, x approach infinity, you divide the numerator and denominator every single term by the highest degree of the denominator
Of the one before.
of the functions.
Okay.
Yeah.
Oh
Okay.
wait, we did learn.
Yeah. Okay, next one. Bye-bye. There you go. Right, next section is like where you are going to read and create your own equations. The really first thing I want to find out is did you find out the word maximum or minimum? And what is the maximum or minimum is about? Okay, so I want you to pull out the, yeah, read the word in there, a very wordy one. Okay, can you find a word saying maximum or minimum?
Minimum as small as possible.
Yes, as small as possible. Good. You know? Okay, right there, right in. Minimum. You want minimum. Okay, and then I want you to search forward or backward a little bit. What is the minimum? What is the things they want to be minimum with? Is that a surface area, a
surface
volume?
area.
Surface area? So that means you are going to have a surface area formula, and then you are going to differentiate this formula. That's what you want. Okay, so you find that talking about surface area, minimum. Surface area now is your y. You are thinking of it as a y, you want that to be a minimum. Does it make sense? I need to create an equation with surface area. Okay, all good. So the diagram given to you doesn't have anything to label on. So if I say a prism did not give you the diagram, you quickly draw up the prism. Okay, right. And what do you want to label the side? Let's label it the same way. What do you want to label this side?
X,
X. And what do you want to label that side?
Y.
Y. And this one? Maybe the H. Alright. So having this, what can I do? From the first sentence, what can you write?
Volume.
Volume. So how do you find the volume for this, the one that we have at the moment?
X times Y times H.
Yes, equal to, what's the volume?
512.
Yes, X times Y times H equal to 512. This is the really first equation I can create from the first sentence. Right. And the second sentence.
The length is twice the breadth.
Okay, the length is twice the breadth. In our case, do you want to write X equal to 2Y or Y equal to 2X? It doesn't matter. Right.
Whatever.
Yeah. Which one do you like? We were all Y equal to 2X, so we all keep
Y
the same.
equals 2x.
Yeah, we keep it Y equal to 2X, so the Y, I cross it out, I write as 2X now. Yes, so that helped me out. That means I don't have to worry about this statement anymore, is that right? Yes, so that means I can change the previous statement because of Y, change it to 2X. So I can say X, 2X times H equal to 512. So that means I have 2X squared, H equal to 512. And I can divide it by 2, 512 divided by 2, 256. And okay, the next step what I'm going to do is I either make H the subject or X the subject. But at this stage, you do not know which one to make the subject. I normally leave some blank space in here. I'm going to fill that in later. Okay, don't write straight underneath it. Yeah. Now, talking about what we want is the surface area. So can you use this to find the surface area? Okay, the base, 2x squared times 2 because you have the bottom and the top. So 2 of 2x squared. And the front, x times h times 2. So you have plus it by 2xh. And then the side, this one, 2xh times 2, that is 4xh. We have all
2x squared.
2, why is it 2x squared? The bottom, x times 2x.
Oh.
That's why I have 2x squared. And I have 2 of them because top and bottom. Right? So add them, simplify them as much as you can. So I will have it as 4x squared plus it by 6xh. As what we mentioned before, you are looking for minimum. That means I need to do the SA, the something. Is that right? Okay, if you don't like the SA, you can keep it as A. So you can write the A, the something. Okay, by looking at this, I have X, I have H. You have 2 unknown. You are not allowed to differentiate. I cannot say the A, the X, or the A, the H. I can't decide which one. So you want to get rid of one of them. This is when you look back to this one. Is it easier for me to make X the subject and sub it in? Or is it easier for me to make H the subject and sub it in? If I have X the subject, I'm going to have root, isn't it? Not nice. I'm going to, yes, I'm going to make H the subject. This is when I decide. Alright, so go back to that. I'm going to make H the subject in here. So 256 on x squared. Now I can sub this H, replacing that one in. Yeah, then I have everything in terms of x. Even though the questions, if you read it carefully, find the height. If I sub it in, that means all my height is gone. Is that right? But doesn't matter. If you're able to find out the x, you can put it back in and you can find the height. Okay, to make your life hard, I put in the square root in here. Right, something not to do. So sub it back into here. So therefore you have 4x squared plus it by 6x and the h is 256 on x squared. Following me so far? Right. Cross out as much as you can, times it in. Yeah, can you put it in calculator and see what you get? So you have 4x squared plus it by these 2 plus out 1,536 on x. Yeah. Now these equations, everything in terms of x, which is good. Now I can start doing. Think of this is your y equal to x sum. To find maximum minimum, what is the first thing you have to do? You have to find it. Yes, differentiate, find the stationary point, and then determine the nature. So almost identical as what you did earlier, except they are not saying the word stationary point. But you still have to do the stationary point. You still need to check for max or min. Yes, there's the meaning of applications. So bring it up first. So 4x squared plus 1,536 and x minus 1. Then we start differentiate. So dSA and dx. Okay, this one, SA is fine. We think of it as a surface area. Yeah. And the normal differentiations. So you are going to get 8x. And after differentiate, what is the first thing you do?
0.
Yeah, at stationary point, you still write the same thing. At stationary point, dSA dx equal to 0, then you have 8x. I'm going to bring the negative index down again because I try to solve it. I do not deal with negative index. Bring it over, times x squared over, and then you get x cubed equal to 1,536 on 8. So x would equal to cube root of something. What is cube of that number? 1,536. 192 or something like that.
5.76.
Yeah.
How do you get 3?
How do I? Oh,
Oh wait.
I yeah. So I did is 8x cubed equal to 1,536. I times every term by x squared. Yeah, x squared.
Yeah,
x squared.
5.8.
5.8. Okay, keep that as a, save that in your answer, or else write a few more decimal places because this is not the final answer we want. We are going to start that back into the x that we have earlier, into this one. Yes.
Solve it in.
Yeah, because the question is asking to find the height.
Yeah.
Yeah, at the moment we are finding x, we are not finding the height. So to find the height, you have that. So you have 256 on whatever the number you're having, which is 5.
Which equals 7.6.
7.6, yeah, you have the h. Okay,
Wait, why was
Yep.
the h before 5.8?
that is not h, that is the x.
5.8 squared.
5.8, no square? I don't think there's a square.
No, for the h one.
For the h will be, yeah, it will be 256, 5.8 squared. Yes, you're right.
And then, is the
Mm.
unit centimeter?
Look at the question, probably yes, because this is milliliter, yes, that means it's centimeter. Right, and one thing that we haven't done, we haven't checked whether it's minimum, right? So we only find out the turning point, we haven't determined the nature. So look at your first differentiation, which is this one. Is that okay for me to do a second differentiation? Yeah, pretty straightforward. So I'm going to do a second differentiation. So I'm going to do the SA. And then,
Do you square the bottom as well?
yes, I put my square on the wrong spot. Square, and then x square. Yeah.
Wait, so to get h, you just sub it in, right?
Yes. So you got 8 plus it by 1,536 times 2. 0.07.
72.
Yes, x minus 3. And then you sub in your x into here. And I'm sure you are going to get a positive number. That means it's concave up. That means your curve look like this. And therefore you have a minimum.
Wait, what was the times by? 7.6.
5.8 into here. The x into the x. The 5.8 is your x, right? You should be getting a positive number.
23.74.
23.74. Yes, see it now? Yeah. And because it's concave up, therefore it gives you minimum. So now you prove it is a minimum, and the h is there, and we are done. If you want to, you can go to a final conclusions. Yeah. Therefore, as small as possible.
You
Yeah.
subbed 5.8. Is that because it's not the exact value?
You sub in this number, whatever that number is, 5.8. You save it in your calculator as a limit, or you leave it as 5.8 is fine, because what we need is either it's positive or negative.
Wait, but wouldn't you get 0?
Zero.
Oh no, that's the concavity.
Yeah, this is a second derivative.
Oh, that's the
Yes.
secondary. Oh, we have to
Happy
find the
with that, your
concavity.
skirt?
My boot and then when I move, it's like
Crutches.
my crutches.
Wait, is it like? Wait, we have to find the concavity, right?
Yes, this is a concavity. It means,
Wait, but could you also find it by drawing the table up?
yes.
But that's just longer.
Yeah, because of the these equations, it's very straightforward for me to differentiate. If this is a hard equation, just like the rational function you had before, I probably will not differentiate. I will just do the table of value.
But this one.
Yeah, this one is easy. Normally, unless you have a square root on it, otherwise I normally just do differentiations. Yes. All good? Yeah. Okay, this is the very first type where they give you a shape. Okay, if you look at the next questions,
Oh, no shape.
no shapes, draw your own.
Oh no, a farmer.
Wait, but how do you make the rectangular? Because they don't tell you how rectangular it is.
This is very confusing.
Rectangular, just draw any rectangular, any side you want. You can draw a rectangular, which is looking like this. You can draw a rectangular, which is looking like that.
This isn't 3D, right?
No, it's flat. It's 2D. Yeah. So
No, but
this
how do
is
you
a.
how do you know if the longer side is at?
Oh no, you don't have to know that. You can
Oh.
draw a rectangle, which is look like that.
Okay.
Yeah, this can be the stone wall. Yeah, this can be the stone wall. Doesn't matter which way you draw, as long as you have one wall, which is called the stone wall, right?
I need to say it's a stone wall.
Yeah, for your own reference. Otherwise, you are going to put an X in there because that
Do you
wall
put
is
pebbles?
okay. So and that means this thing in here is the fence, right?
Yeah.
Yeah. Okay, let's do them the same way. The two parallel side, what do you want to call them? X and Y. X. So we call this as an X. The other side is a Y. If you draw it this way, these two are the X. This is a Y. So we just make them the same. Okay. But if you do it by yourself, you can do it anyway. Right.
Okay.
Yes. Okay. So from the information, what can we write? Yes. From this piece in here, from the questions.
2x plus y equals 100.
Yes, that's the first equations. 2x plus y equal to 100 because it's 100 wire, whatever that is, going to fence it up. The three sides. That is our first equations. Okay, now I want to look through the equations again, the question again. What is the minimum or the maximum they are looking for? Maximum of
100.
what? What is the
Fencing, fold.
100 over the
No,
fence.
no? What is
As
the
much area as possible.
as much area? So you want a maximum of area. Yes, that's what you want. So that means you need a equation of
Area.
area. Yes. What is the area? Look at the diagram we have. Area
X
will be
times y.
yes. Can you differentiate if you have x times y?
No.
No. What should we do? Because we have this equation.
Change that equation.
Yes. Am I going to make y the subject or make x the subject?
One
Why?
subject.
Yes, because it's easier, not for any other reason.
Bro, I want to go to IKEA.
That is not relevant.
So
I don't actually go to IKEA a lot.
x, and then the y
I do
becomes
love that the minimum is
100
5.
minus 2x.
Wait.
Are you okay?
What happened? Are you alright? So y, I make y the subject,
Oh, whoops.
and then sub into
Oh,
my
shoot. I was looking at the wrong thing.
And what else can you do? What should we do from this equation? This is your main equation. So what do we do? Last lesson. Differentiate, find the stationary point, determine the nature, and then answer the questions. That is will be the two steps you have to do every single time.
Wait,
Wait,
what
what?
would it be over?
Repeat that?
dA over dH?
dA over, there is no h?
D.
dA over dx.
Yes.
Okay.
Wait, what's the value you're differentiating always goes on top and then like the
This is go on top,
yeah and then
this
that
is go
one.
on bottom.
What was the two steps?
Stationary point, determine nature.
Mm.
Yes.
Bro, wait, I feel like I've done these things before.
We have this was in one of our year 10 tests and then like
No,
but you had to do it by drawing the graph
Yeah.
instead.
I feel
And I
like
watched like Liz and Mr. O talk about it and I was so confused.
No, I think I did this before I dropped.
Oh really?
Yeah, like I feel like I did this recently.
Damn.
Yeah.
Okay, so how do you differentiate? What should you do?
100.
Expand it.
Expand. Yes.
Oh,
It's 100
Expand.
minus 4x.
Yes, 100x.
4x?
Oh,
Just
after the
expand it.
differentiate. Yes, so 100x minus 2x squared.
I tried to
So you
show
have
it, but
dA
oops.
dx
This
is
is why
equal
you
to
can't show
100 minus 4x. And then what are you going to write? At.
At
Yeah. So at stationary point. This is what we
X
got.
equals 25.
Alright, so we have stationary point. Then we need to determine the
Y.
nature. Yes.
Oh,
which one do you first?
You want to find y? It's fine. Go ahead. Yes, let's find out the y. Why
You
not?
have to.
Yes, for this question
So it's
because
50.
they're asking you how are you going to make the phone.
50 meters.
Yes, y is 50.
25
Yep.
meters.
Some question you don't have to, but this question, yes, you are going to find out. Eventually you do. Right, then you are going to find out the second derivative, d squared a dx squared will be minus 4. Ah, this is so nice. I don't even have to sub in the number because this is always less than 0. It's always concave down. When this is concave down, that means it creates a
maximum.
Okay, conclusions. How are you going to make the fold? You have to have you know the x is 25.
Yeah.
And then the y is 50. So you can say the two parallel sides should be 25. And the one opposite to the stone wall should be 50. Yes.
Do you write that?
Yeah, you write that as a conclusion to answer the question of the questions.
Wait, do you have to prove the nature even if they don't ask? Oh, we have
They
to prove
do
it's a
ask.
maximum.
Yes, they do
Oh.
ask.
what do you write?
The two parallel sides must be 25 meters and the side opposite this giant wall.
Is 50 meter. Yeah. Always have to prove. That is a common thing students forget is the proving. It's an easy part because in
Side
exam you
opposite?
rush through.
Yeah.
Yes,
opposite
always
the same.
remember. Prove it, prove it, prove it.
Wait, should we say is or like must or it doesn't
It
matter?
doesn't matter.
Okay.
Yeah. Next teacher don't care about the grammar or the real sentence or no real sentence is fine. Oh good. Okay, question 3.
Area enclosed by the line and the two axes big
Yes.
as possible. So is it area then?
This one is a very tricky one.
It sounds too many words.
Yes, very
This
wordy.
one graph?
Yeah, we want a graph. You want the line. What
I
type
feel
of
like
line
I've
is that?
seen this before.
You see the line 1 minus 2 equal to m.
X.
What type of line is that? Is that a curve or a straight line? Okay, where does this straight line pass through? It passed through what point?
1 and 2.
1, 2. Okay, this is what I will do. Because they are looking for area. I don't even know where is the area I'm looking for. So I put in the point. Yeah, this is your 1. And this is your 2.
Triangle.
This is, yeah, you draw a triangle. So now you're asking, should I be drawing this way? Or should I be drawing that way? And
Oh, I
how
just
stiff
guessed.
should I be drawing? Doesn't matter.
Oh wait,
Doesn't
I did
matter.
that wrong.
Oh, you draw the 1, 2. So, which way should you be drawing? How stiff should it be? Doesn't matter. One thing not to do not draw it. Go through the origin. Something not to do.
Oh,
Okay?
I did.
You did. That's okay for this question, still alright. Yeah. Okay, so I'm going to get rid of one of the line. Okay, so I'm going to get rid of this one.
Oh, what?
Oh,
Do you not draw 2 lines?
No, you only have one.
Oh,
You only have one. You can draw any
But
of the
there's 2
line. Yes.
axes. Wait, what's an axis again?
Axis, yeah.
Exactly.
Oh no.
Oh no.
Yeah.
Too late.
Yes, you only need one. So can you see the area bounded by, enclosed by the line and the axis? Can you see the area? This is
The
the line.
triangle.
Yeah,
The
mine's kind
triangle.
of small.
Yeah, this one. Yeah, that's why I said don't draw through the origin, otherwise you don't need the area. The area is
Oh, are we
okay.
all supposed to have the same line? My line's
No, no.
different to yours.
Yeah, it's okay. You don't have to. Yes, your one can look like, so 1, 2 is here. Your line can look like this way.
Okay.
Because you do not know at this stage what is the line look like.
Okay.
That's why I said it can be any. Yeah. So now to find this area, what is important? What do I need to find out?
The height and the base.
How do I find the height? How do I find the base?
Find the gradient.
Not really. I have these equations. I already have
Find
this.
the x-intercept.
Yes, you can find the x-intercept. You can find the
Why?
y-intercept. How
So
do
do
you?
you just insert it?
Yeah. To find the x-intercept, you put
Y.
Why?
0.
yes, put y equal to 0 into the equations. You have your equation y minus 2 equal to m, x minus 1. Okay, so let's put y equal to 0 to find the x-intercept. And therefore your x equal to, is that minus 2 on m plus 1. Okay, so I know this point in here is minus 2 on m plus 1. Look horrible, but it's alright.
Wait.
Yes.
That means I did it wrong.
What do you mean I did it wrong? You put
But it's
x
not
equal to 0?
minus.
Minus 2 on m? Yeah, you have the same thing.
Oh, can I still put it this side?
Yeah, doesn't matter. I do not know what m is. M
Oh
can
yeah.
be
Okay.
can be 5, can be 20. Yes.
Okay.
Yeah, I do not know which side, doesn't matter. Okay, let's find out this point then. The y-intercept, that means you put x equal to 0. So that means when x equal to 0, your y minus 2 equal to x equal to 0. So you have m minus 1. So y equal to minus m plus 2. So this one is minus m plus 2. So what I need is the area. So let's find out the area. Area equal to? How do you find area?
Minus m plus 2
Yes.
times minus 2 over m plus 1 divided by 2.
Yes, times it by minus 2 over m plus 1 divided by 2. That means I times it by half. At the moment it looks pretty sad because it's so many terms you are having in here. So this is the area equation. That means I need to differentiate this. So it's up to you whether you want to expand or you want to use a product rule. I probably would just expand. Yeah, I don't like product rules and I don't have to. So I'm going to keep the half outside and then expand this piece in here.
So times everything by a half.
Yes, times everything by a half in the front. So I'm going to write a half outside. And then you have minus become plus. So you have a 2. And then minus m. Minus 4 on m. And then plus 2.
Oh,
Wait,
like that. Like that.
Yeah, I just expand. I just do my normal expansions if I did it right. Close to
Is that a
two.
2?
This is a 2, yes.
And then what is the middle bit become? What's
What is this one? Oh, I'm not going to join them because I need to
Yeah.
differentiate. If I join them, I have to use a quotient rule again. So I keep them as individual as I can. Yeah, that's why I have them pretty bad.
I don't have to expand the half, do you?
You don't have to and you do not need to because when I differentiate, the half stay as a coefficient in the front. So the most I will do, one more step is I add these two up. But if you don't want to, that's totally fine because you are going to differentiate it the next step. Okay, they are going to turn to be 0 com. So the next step I have to do is I bring this one up because differentiation, I like it to be on the numerator instead of denominator. If I do that, I will probably just add these two numbers up there. Okay, so I'm going to have a half equal to then 4 minus m minus 4m minus 1. We can do that.
Wait, but don't you still need to do product rule then?
No, no product rules. Why do you think of product rules? Because of the half.
Yeah.
A half is a coefficient if you have y equal to 3x squared. The 3 is a coefficient, you don't do product rules, right?
Oh yeah.
Yeah.
You don't even need the chain rule, right?
No, that's why I try to avoid every single rules if I can. Yes. Okay, if I can expand, simplify, I will do that. Right, let's differentiate. The a, the n.
Wait, why don't you need the
Yeah.
chain rule?
Why don't we need a chain rule? Because I don't have a power here.
Oh yeah.
Yes, so that's why I don't have to have a chain rule. So we are going to have a equal to the m equal to, I will still keep the half. Differentiate 4 gone, differentiate m minus 1. Differentiate that, I have 4m minus 2.
How is it minus though? Isn't it
Isn't it
minus 4
plus?
times
A
minus
plus, yes, it is a plus, thank you. Right, then I'm going to look at stationary point. Yes. So we have half. Okay, I'm going to bring the m back down because I want to solve it. I don't like to solve using negative index. Okay, I can times 2 to both sides, then the a half gone. So you're left with minus 1. After finding m, what do I need to do? You
Take
done?
away the negative.
Oh no,
Oh,
you
no.
can't. You can't. Because m
Nature.
is great. Yes, determine the nature. So now I look back to here.
Do you
Can
differentiate again?
Yes, this is easy to differentiate. I will differentiate again. So that means I will determine the
minus
nature.
8m minus
The square a, the m square, I have a half minus 8m minus 3, which is minus 4 on m cubed. So if
Minus
I
4.
test for,
Oh.
yeah,
Oh.
cross it, yeah.
Oh.
So when m is minus 2, my d square a dm square equal to minus 2, that be 1 on 2, which is greater than 0. This means concave. Up means minimum. And are we looking for minimum? Or are we looking for max?
No.
We are looking for max. So this one is not what you want.
Do I cross it out?
No, you don't. You just leave it there. And then you test for when m equal to 2, d squared a dm squared equal to negative a half less than 0 in concave down. And this way, that means it gives you a max. Now you can draw your conclusions. Yes, conclusions. Therefore, maximum area will happen when n equal to 2. You done your proof, yes and a no. So for the question before this, is only one solution, and that solution is your solutions.
Wait,
And-
what do you say again?
Go back to the questions and see what is the questions asking. You want to look for maximum area, right?
m equals
Yeah.
2 will make the area enclosed by the line and 2x as big as possible.
Yes. You can say enclose the biggest area if you don't want to say so wordy. Use your English skill.
this so difficult?
I want to find that this is easy because I always consider this as a free mark that you should be
I
getting.
feel like this feels like the type of questions like you need to get in the rhythm and then it's really easy.
You just need to. It's a routine.
Yeah.
You have the
I like
two
these
equations. Sub one into the other. You have been doing that, right?
Yeah.
Kind of two
I like
equations.
how it's
One
very
is having two
sequential.
unknown. This equation is the one that you need to
It's just
differentiate,
So, just so teaching.
right? So let's look at what. Let's summarize what you have to do. Yeah.
No,
Look at this.
There's like
You have one
sequence
equation,
for everything.
okay, and then you have the second equation. This equation is not the one we want to differentiate. This equation is the one that you are going to sub into here to help you on the differentiations. We have been doing like two of these, almost identical. And the maximum and minimum is the part that you need to find out what is maximum. In here, we are talking about area maximum. So that means you are going to differentiate your area. Find the stationary point by putting the dA dx equal to 0. And of course, you are going to find out what they are. Okay, so for this question, find out the x. Do you need to find out the y? It depends on the questions. Some of the questions they are asking you the length. They don't ask you the width. So this is not necessary. But this question they ask you how are you going to make the fold? So that means you need both of them. Alright? So up to in here, in this step, it's up to you whether you want to find this or you find this at the end. All good? Yeah. Determine nature is the one thing that you have to do. Maximum, minimum, find out. So in here, you only have one number and you don't even have to sub it in. It's always give you concrete down. And while for the other questions, this one, you have two answers. Okay? You are not allowed to reject anything in here. You need to test, make sure one of them is concave out, one of them is concave down. Really, really unlikely you have both concave out. No. Oh, good? Yeah. Do something similar on the next questions. Try again.
Is this cylinder?
Cylinder, what is the cylinder? No, cylinder area or volume?
Volume.
Volume is
volume?
area of the base times it by the height because it is a prism.
Oops.
Oh god, I don't know.
Yes, the volume of a
Forget
cylinder.
all this.
Okay, so if this is my cylinder, I
Oh, so
use,
it's pi
This is
r
R.
squared plus h times h.
yes, volume equal to pi r square h. If it is a closed cylinder, the surface area equal to top and bottom, which is 2 pi r square times it by 2 pi r h. If you have an open one, the surface area will be pi r square because it's only bottom and then the side. This is the close.
Wait, so what's the
This is
minimum
open.
associated with here?
What is the minimum? Okay.
Is it associated with radius?
No, what is the minimum? This question, I want you to read really carefully, use your interpretations, and what is the minimum? It doesn't say very clearly what is the minimum.
Area.
Radius.
Area,
Surface area.
surface area, because they use as little metal as possible,
Yeah.
that means talking about surface area. This one, you need to interpret a little bit more. Okay, but you were given the volume, right? Were you given a volume?
Wait, yeah.
Yes.
Wait, what is volume?
Yeah. The volume is in terms of milliliter. Whenever it's milliliter, that means in terms of centimeter
What is
cube.
the other? Oh, those are just the formulas.
Yeah. This one is a close, so that means top and bottom. This one is an open, that means there is no top. You already opened up the cap. Yeah.
Wait, so this one is not opened.
This
Not
one's
open.
closed.
This one is closed. Yeah. And
So
unopened.
that's the first equation.
Yeah, that's the first equations.
That's the
So
one that helps us, though, right?
yeah, that is the helper. Yes.
So
Now
this
you
one
are
is the
looking
one
for
we
the
wanna
surface area.
differentiate.
Good. Yes. So your volume you given 1,000 equal to pi r square h. So eventually we might make h the subject or r the subject. I leave it
H.
open.
Oh.
Yes. Yes. Most likely to be a h.
And then do you insert it into the surface area?
Yep. Surface area equal to pi, is 2 pi r square. Yep, very likely we are going to sub in the h, right?
Yeah.
Yeah, it will be easier. H will equal to 1,000 on pi r square. Sub this in.
What?
This,
Oh, we're moving on now.
yeah.
And then do we differentiate?
Yes, you do the SA the H, the R. Yes, you don't have H. Your H is gone.
Differentiate that.
Yeah, did you sub it in already?
Yeah.
Yeah. And did you simplify it after you sub it in?
No.
Simplify the R with this, the
Oh,
pi with that. So you have 2 pi R squared plus by 2000 R minus 1. That is your surface area.
$2,000 over R.
Yes.
Yes.
Yes, yes, yes. And you can do the SADR.
so it, nothing happens to the pi, just stays there, right?
Yes, pi is just a pi. Yeah.
Nice.
Minus, yes. Good. And then you write the statement. Yeah. Good. Good. And bring the R back down to the denominator.
Do like this.
Okay, what did you do here?
I cross these.
How?
Can I not cross it?
How do you cross
I
it?
don't know.
You cannot cross it.
Oh, oops.
You times it all by R squared.
Yes, you times it by R squared.
Oh, whoops.
Yes, you cannot cross them.
So it'll be
Okay.
R cubed, right?
Yes. Yeah, you times every time by R squared to get rid of the denominator.
This one by R squared too.
Yeah, every time.
I don't trust.
Cube. Oh, sorry.
I can hear you rattling. Wait, what are you doing over there? Why are you using your calculator?
I don't trust myself to divide 2,000 divided by 4.
Wait, that's so true.
Okay. And then what do I do?
You divide the wrong thing. I would, yeah.
Oh,
Find
no.
it out. Where's the radius? Yeah. So R subject.
And then it's bigger than. Oh no, this is
No,
not the
no,
one.
no, 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 no.
And then I have to differentiate it again.
Yes, you have to differentiate again. Good.
Jeez.
Where's the
Mm.
double
And
derivative?
then differentiate again.
Yes, yes. To determine the nature, right? Yeah, good. Everyone is going smooth now.
Where does the square go in here or?
The square here in the middle. For example, the square y dx square. Yes. Which one is it? Yeah. Good.
So it'll just be 4 pi
4 pi
plus 4
thousand.
minus 3.
Now you sub in your r into that equations and see whether it's greater than 0 or less than 0.
No, I'm pretty sure.
Wait.
It's greater than 0. It's greater than 0.
Yes, greater than 0 means
Did
concave up or
you
down?
get 37 point like something?
Yeah, up. Concave up means is max or min?
Min.
Yes. Good. Now we can answer the question. What is the question? What did you find?
Oh, wait, we did different things. But it's okay. I still got a positive number.
Therefore, radius should be.
Your arm should be 5.4.
Damn. Oh, wait, no, that is my thing. I didn't,
Centimeters? Oh, centimeters.
I didn't
Centimeters if.
put it into the calculator. I just.
The should be 37.
Oh, I think I just put it on a calculator.
Yeah.
What did Ivan tell you about the flight?
Oh, he just said Angan and
Alvin Khan.
Evan Kong.
no, he was
Oh,
punching
Ahmed.
Auckland Bella first, and then Ahmed
You
started
sub
punching
in
also. I
your
was like, I
R
forgot.
His
onto
arms.
Yeah, I heard he said like it was like
this
batted up.
4,000.
Imagine
Yeah,
going home
your
with
equation
friends
look
and
right.
like,
Yeah, I think I just
Yes,
put it.
yeah.
I'm concerned actually.
actually very bad. That is very bad.
What even started it? I think what's it called?
He like they
Ivan
made
was like, oh, I don't even know what started it. It
no,
just happened.
they made like a catfish account. And
What?
Like,
Of who?
like some just a random person.
Do you know that's like a really big thing? Like people like I didn't realize people enjoyed catfishing each other that much. I didn't realize that many people got catfished.
And then he said,
Oh really? Wait, that's so embarrassing. Wait,
Wait,
that's
did this
actually
happen
so
to-
embarrassing. That's so embarrassing.
Should we move on to the next one?
Oh my god, it's so embarrassing. Wait, how do they even plant it? Wait, how does that even work? Like, how do they even do that? Does he not think it's
differentiate
sus?
twice.
Yeah, this one.
Yeah,
the
that's
nice
what
thing
I'm
is the
thinking.
equation is given to
Wait, why
you.
does he not think?
Yeah, you don't even have to find out your own equation. It's already given. So it's just like normal thing.
Is it dp over
Yeah, dp dt. That's right. Because you have a population, you have in terms of t. So dp dt.
Okay.
Wait, what's happening?
Yes, and then at dp dt, what do you need to do? At
Stationary point.
always. Because you are looking for population maximum. P dash.
Oh,
Yeah.
does it matter?
Oh yes.
Oh no.
Because you don't even have a y there.
Okay.
Stationary point is which one equal to 0? This or that?
Oh, this one.
Yeah.
Wait.
Factorize. Bring it over. Okay.
I do
Have a
that.
good habit. Do not cross out the t. Bring it over. Factorize it out.
Okay.
Yes. Otherwise, you lost your solutions.
Okay.
You cannot divide. Factorize. Bring it minus it.
Oh,
Yes.
okay, sorry.
That's how you solve quadratic.
T equals 4.
Oh, you also lost your answer. And t equal to 0.
Oh, yeah.
Yes. Cannot lose it. Okay, then you decide. Second derivative.
Wait, what do you
Sub it
mean?
in.
Oh, yeah.
Maximum or minimum. Factorize the common factor.
Oh, okay.
Yeah, quadratic. 2 solutions. Yep. -4. Yep. So you have. That's right.
Oh,
Yes, you have 2 solutions. If you lost one, you lost 1 mark.
yeah.
Mm.
And then also it should be 4 years.
Oh no, there is no shoot. You need to test out.
With the double.
Yes, there's nothing called shoot. Okay.
Oh,
Mm.
gosh.
Okay. So what does it mean when you have that? It means.
So next.
Yes. So that one.
Wait,
is
what's
max.
the phrase you need to say for this one? Do you have to say a
No,
phrase?
no, we don't.
So
You can
just
say
zero.
at t equal to 0, second derivative equal to.
Wait, t equals 0. Isn't it the differentiative? Isn't it this side equals 0?
No, you have that is point of inflection. You are doing testing at the moment. You want to see whether t equal to 0 is concave up or concave down. No. T equal to 0. You want to test this point is the maximum or minimum. You want to test this point is maximum or
Oops.
minimum.
Okay.
Good. Okay, and the second question, what is the maximum populations?
So you just sub it in.
Yeah, you sub in. What are you subbing in?
At 2.
T equal to 4. Yes, t equal to 4, you sub it in.
So it's
Which
minus
equation?
12.
In the
Wait.
normal equation?
The normal equation represent.
Population.
Yeah, you are looking for populations.
Wait.
Yeah.
Just make sure I do
Yeah.
the minus.
Yes,
Is that
yes.
what? Is that how it's
Yes.
meant to be? The minus on the
Yes.
outside.
Yeah, minus is outside. Yes.
Yeah.
Yes.
Okay.
Wait, am I
Yeah.
doing this correctly?
Yeah. So what does this mean? When you have your second derivative is 12,
So it's greater than 0.
you write down greater than 0. And what does greater than 0 mean?
concave down.
Yeah, concave.
Oh, it's concave up.
Yes, and what does concave up mean?
This
Yes, that means it gives you.
minimum.
Yes, that is what you do. You stop there. Good. And question 3, sketch the graph. Okay, again you have a boundary from 0 to 6. Make sure you sub in 0 into the equation, find out the coordinate.
Sub in 0.
Sub in 0, sub in 6. You need the point because there is a boundary, it's not an arrow.
Wait, so when?
Yeah.
So wait.
Boundary, sub in number.
So you sub in both sides.
Yes, yes. Because your curve needs to start at 0
And then what does that
and at
give
6.
you when you sub in?
What equation did you sub in? Which equation do you think you need to sub in?
You sub it into the normal one, right?
Yeah, the normal one. What are
And
you
then-
getting? You get populations because the normal one is.
So does that
populations.
show like that doesn't show the asymptotes, does it?
No, there is no asymptote. This is
Oh.
not rational. This is just a cubic curve.
Okay.
Mm.
So that's just a boundary, full stop.
Yes, where
Okay.
you stop, where you start.
Okay.
Yes.
So is the population 9? Wait, what? Wait, I don't know how I got this.
Where did you sub it in?
To the original.
How do you get that number?
Wait, I don't know.
This is a 6, not a 3.
Oh,
It says
my
57, but you got 25.
brain is so broken.
When you are at 6, not 4, you sub in the 4.
Oh my god.
Yeah.
Wait, do we sub in 0 and 6?
To find out
Sketch.
you know the maximum point, you know the initial point, you know the end point, then you should be able to join them. And the 0 is the minimum point as well, right?
Oh, 25 again. Wow.
So you start at 25, you end at 25 for your graph.
So let's just.
And the highest point is go to is 57.
Wait, are they both 25?
Yeah, initial and end.
So 0, and then 6, and
So how do I do it?
You have, is this point maximum point or minimum point? You did not do your conclusions. You have, when you have greater than 0, what does that mean? Second derivative greater than 0 means
okay.
minimum point. So that means minimum point happen when?
T equals 0.
Yeah, that this one should be your minimum point.
Like this.
Yeah, minimum, that is what minimum point represent here, right? And what other points do you have?
When T equals 4,
Yeah.
it's a maximum.
Yep.
So like this.
T equal to 4, what is your y coordinate? What is your
T equals 0.
T equal to 4?
Oh,
Population
57.
is, don't just randomly put the number.
So 4, 7. And then we're going down.
And then the end point?
6.
Yeah.
Wait, 4. So it'd be like this.
This is a minimum point.
Oh, so it got up.
Minimum point, that means it should, this is your max and should be, minimum point supposed to go this way, right?
Yeah,
Is there
but
a
it's only
bounce?
from 0 to 6.
So it should go this way. This is your 6.
Is there a bounce somewhere? Or am I tweaking?
You have, this is your minimum point. So
Yeah.
imagine yourself having a curve going down this way, don't draw it, and then you go up. Okay?
How do we know?
When was the population
Oh well, I
equals
guess it is the
0?
minimum because that's where the graph.
You
cuts
should
off.
already done it here.
So does it look like this?
Your second derivative? Ooh, you have it on the, you did not do the testing. Yes, you did. Yeah.
Oh, I did. Oh,
T equal
yeah.
to 0 is the minimum point.
Oh wow. I
This is
forgot
a
about
maximum
that.
point,
Wow.
and this is your end point. So it's more like
Also, the technically the like double bounce would be here.
Yeah.
But you don't do that. 'cause
You don't
it
do
cuts
that,
it, So it would be
yes.
like.
Yeah, and then you curve up, and then you go to the max, and then you go down, and then you stop. Done. That's what we
If
curve.
if I did like that in the test, would they like
this is a curve. No arrow. You start at 0. You stop at 6.
So I just stop there.
Yes. Don't make it so tiny.
Yeah, because I saw the 25 and I was like, oh no.
But why are you
Because
having
I
it
did
open?
buy at 5s.
Oh. Don't do that. You only have 0 to 6. Only 0 to
So-
6.
Oh, it's 20.
Okay.
5D.
Yeah. Okay, finish off the rest as
How
a
do we
homework.
do D? Do we just look for eyes?
Okay, the D is when was the population increasing most rapidly? That means when the population going up the fastest. That means is your point of inflection. That means second derivative equal to 0. That is when. So because of this, at that point, point of inflection is the steepest of your curve.
Yeah.
So this point is the steepest. You are looking for the steepest point. So that means you put your second derivative equal to 0.
Do we have to say at point of inflection?
You don't have to. You can say at second derivative equal to 0.
Oh.
Yeah. Or if you want to say at point of inflection, that is totally fine. Yeah, nothing wrong with that.
Wait, we have like only 3 questions.
Yep. And this one.
Oh no.
More?
The transformations we talked about
Oh god.
last week.
Oh,
Yes.
yay.
These are some sketching that I want you to do.
Wait, I actually can't sketch this. Okay.
Yeah, it will be on the AP
Oh
script.
gosh.
Yes.
Wait, I actually can't sketch this.
Yeah. All this will be in your AP script.
Actually, I sketched the graph.
Yes.
Sketch
We should
all
Sketching
that
and
before.
problem solving. Bring these two back next week.
Okay.